Okay, so in this problem, we got number 8 from the procedure section. And in this problem, we had a dishwasher, that is this, with a hollow hole here, that is exactly 2 centimeters in radius, with like an outer ring, that is this one, that changes from 5 to 5.5. So first we get the equation to do this. So we have the formula for the area of the circle minus the hollow part, that is 4 pi. We got this by doing the exact same thing, that is the area of the inner part, and then we subtract it to the other part, but it was 4 pi, so we wrote it like that. Then we get the derivative of that, and we get 2 pi r. Okay, and we have also dx here, which is 0.5, that is the rate of change. Here, in the first one, in number A, we subtract the initial value minus the whole part that is in the middle. So what we do is this by doing the bigger one first, so we get positive numbers. So we wrote here the formula of the area of this big circle. We wrote here, and then minus the whole part. Then after that we did the same thing with the inner ring, with the minus the whole part, and we got this answer, 21 over 4 pi, that is equal 16.493. Okay, so now we want to get dy. By doing this, we know that the formula for getting dy is dy equals f of x prime times dx. That is the formula for dy. So we know that the function is this one, that's why we got the derivative, that is 2 pi r. We insert it here, and then we multiply it by dx, that is 0.5. We put the numbers in here, and we get the answer, that is 15.707 centimeters squared, which is a lot similar to the answer we got first, that is 16.493 centimeters squared.
For this second part of the problem, part C, we use the same figure that we used in the past sections, but this time they add a thickness which is 15 millimeters, which comes out to 0.15 centimeters, which we use because the other units are centimeters. And so first we need to find the accurate change in the two x's. So to do that, we get the formula for the volume of a cylinder, because they ask for the volume. And so the formula for the volume of a cylinder is this, pi r squared times height. And so then you multiply, you plug in the x values in the equation, the bigger one first, and the answer is 2.474 centimeters cubed. That is the accurate change. And then to find the approximate change, we get the derivative of the formula, which is 2 pi r h, and h you leave it alone because it is a constant value, since it will be the same for both x values. And so then we know that, again, the formula for dy is what was written here, dy times f prime times dx. And so we just plug that in, which is f prime of x is this, and dx is 0.5. And the answer is 3 over 4 pi, which comes out to 2.356 centimeters cubed, which is very similar to the other answer. Both of these problems are very important in the context of an engineering company. Surface area is important because it tells the engineering company how much space the part will touch with another part. And the volume is important because it tells the engineering company how much material they need to build this part. And obviously they will need more for the 5.5 compared to the 5, and this tells them how much they will need.
Okay, for this problem, you got this fraction. You have to convert the fraction into 3 different fractions. From here, you gotta simplify. So you got 5 plus 6x to the fifth to the second, yeah. And you gotta subtract this x to the third, so you get 5 plus 6x to the negative 1/2, and then you just have the negative 7x to the negative 2. Then you do the antiderivative, that gives you 5x plus 2 times 6x to the 1/2 minus 7x to the negative 1 divided by negative 1. So this is the answer. 5x plus 12x, 12 square root of x plus 7 over x plus 8.